Hi there. So as promised, I thought I would do two more examples, actually repeat one example that we did right at the end of class, and just so that you had it, and then show another way to do it with a confidence interval that we kind of went through really quickly. And I didn't talk a lot about when we were in class today. So the example again with the favorite color, we have Dulux Paints conducted a survey and found 42% of males say their favorite color is blue. Haley, a statistics student, surveyed 150 randomly selected college-age males and found 40 said their favorite color is blue. And does the result suggest the proportion of college-age males whose favorite color is blue is different from the Dulux survey? So here we notice that we're given that our population proportion is 0.42. That is from the 42%. Okay, we just turned that into a decimal. And then we notice that here we surveyed 150 randomly selected college-age males and found 40 said blue is their favorite color. So that means that our X, the number who are in the category or have the characteristic, is equal to 40, and our sample size was 150, so n equals 150. So from that, we can calculate a sample proportion that's equal to x over n, and that's equal to 40 over 150. And if you use your calculator to figure that one out, you get 0.2667. Okay. All right. So we have that. I'm just kind of putting stuff together that came out of the problem. Now we want to start by identifying our null and alternative hypothesis. So we're going to say our null hypothesis, H aunt, is going to be what we currently know, right? So that's that 42%, that our expected population proportion here is 42%. So that's what our expectation is for our null hypothesis. So we're going to say P equals 0.42. Righty? And then what we want to know is, or what the statistics student wanted to know, is whether or not the proportion of college-age males whose favorite color is different from the Dulux survey. So we just want it to be different. We don't care whether it's greater than or less than, so we want P not equal to 0.42. Alrighty, so in order for us to know whether our sample proportion is going to be normal, we want to check our conditions. So our conditions, remember, are number one, that it's a random sample. And since it says that in the actual 150 randomly selected college-age males, I think we can effectively cross that one off. We have a random sample. Number two is to make sure that we have a large enough sample size, is that n times p times 1 minus p, and you'll remember this from back in the chapter about the sample proportions, must be greater than or equal to 10. It's one of the conditions. So here, if I look at that, I have n is 150 times p is 0.42 times 1 minus 0.42, and that's going to be equal to, actually, I'm going to move this a little bit here. That's going to be equal to, let's see, 36.54, which is definitely greater than or equal to 10. So we can mark that one off. Number three is that we check for independence, and we do that by saying that we want to make sure our sample size is less than or equal to 0.05 times our total population. Here, we're going to have 150 is less than or equal to 0.05 times our total population. If I divide both sides by the 0.05, then I get that n is going to be greater than or equal to 3,000. And I'm relatively certain that there's more than 3,000 college-age males that would be potentially in our survey, so our population is going to be independent, right? So we've met our conditions. That means that we can assume from here, so let's change colors, we can assume that we have a normal distribution. Let's go up to the top, actually. We can assume we have a normal distribution or sampling distribution. And for our P, for our proportion, and remember, we're going to say that mu sub P hat, the mean of our sampling proportion, is going to be equal to our H aught, our null hypothesis proportion, our assumed proportion. So that's going to be 0.42. And our sigma of our standard deviation of our sampling distribution, we can find from P times 1 minus P over N, and we take the square root of all of that together. So there we have 0.42 times 1 minus 0.42 all over N. Oops, let's put in a number for N, right? We're going to say it's all over 150. Sorry, I was looking at this. Let's move this over. Here we go. We're going to take the square root of that. So if I punch that into my calculator, what you should get out from that is 0.043. All right, so we have a normal sampling distribution with a mean of 0.42 and a standard deviation of 0.043. Alrighty. So what I'm going to do now, 403, sorry, I lost a zero here, 0.0403. There we go. So remember I said we can do this one of two ways. We can look at the z distribution, we can look it up on a table, or we could use StatCrunch for it. So I'm going to do that way first. And then I'm going to add a page here. I'm going to do it the way that we did it in class with StatCrunch. So the first thing I'm going to do is, if I have the z distribution, right, then I know that because I had, let's write this down, I had my sampling mean was 0.42, my sampling distribution was 0.0403, and remember we calculated way up at the top that my sample proportion was the 40 over 150. That's right here. And so that was equal to 0.2667. Okay, and that should be everything we need to get a z statistic here. So I can calculate a z aught, which is what I'm going to use to test my null hypothesis, and that's equal to my sample proportion minus my distribution mean for the proportion divided by the standard deviation for my sample. So that's going to be equal to 0.2667 minus 0.42, all divided by 0.0403. So what I'm going to get if I punch that into my calculator is a negative 3.804. Okay, this is the part I didn't touch on in class. So if I pull this down, then if you look at the distribution, right, we know we're approximately normal. And I know that for a z distribution, I have a mean of 0, correct? And so what I'm looking at is, because my alternative hypothesis, because this alternative hypothesis was a not equals, that means I'm doing, remember, a two-tail test. So what I'm looking at is, I want to look at what the area is over here So this is where my negative 3.804 is. But I also want to look at what's the area out over here. Okay, so I'm looking at the positive 3.804 because all I was interested in is whether or not it was different than what it used to be. If I had asked just for one side, I would have just done a one-tailed test. So in order to find this, the p-value here, what I want to do is find the area of one of these and multiply it by 2, because I have an area here which is equal to p where z is greater than or equal to 3.804. And then I have an area over here that's equal to the probability that the z is less than or equal to negative 3.804. And I want to put them together. I want to add them together because I'm looking for whether or not it's different. And if you remember right, I said we were going to use an alpha of 0.05 for this one, just to start. So if we take a look at this, what we see when we go to StatCrunch, and I'm going to go over to StatCrunch here, and this will come up a little bit different than what you've seen because I'm on my iPad. But if I go to Stat and I go to Calculators, and then it went away, and then I go to Normal, it comes up, remember, with my Z distribution. So I have a mean here of 0 and a standard deviation of 1. So what I'm looking for is a Z-score that I can pick either side of that. I'm going to look to the left, the 3.804, the positive. So I'm going to look for greater than. And if I compute that, what you see is it's not even really on the graph. So what you see there is that we have a z-score of 0.0000719. And if I looked on the other side, like if I wanted to look on the negative side of this and I wanted to pull the negative one, I could actually put that in and I could add them together. What I'm going to find is it's the same thing, which makes sense because it's a symmetric distribution, right? It's so small that it's not even showing up on the graph, though. So if I go back and I take those numbers back over to where we were working here, then what I found was that P of what I want is the two areas added together. So P, the z-score is less than negative 3.804, plus the probability that the z-score is greater than or equal to 3.804 is equal to 0.0000719 plus the same thing again, 0.0000719. Now you'll notice since those numbers are the same, what I could really do is just find the area for one of these and multiply it by 2. So this is the same as the probability, the same as 2 times the probability, let's put the 2 out there, that z is greater than or equal to 3.804. So you're welcome to do that if you don't want to look for both of them, okay? If I add these two together, or if I multiply them together, what I'm going to get, if I do that real quick, I get 0.00014. So usually we don't go beyond those digits. So I'm just going to say that we're going to stop here. So that's exceptionally small. It's definitely smaller than 0.05, which was equal to my alpha, right? So since it's smaller than that, since it's smaller than alpha, and this is my p-value, okay? So this is my p-value. It's equal to that, so this is my p-value right here. And it's just the probability that you're in one of these two tails right here, over on the top, okay? So you're either over here or you're over here. All right, so then what we can say is that there is evidence to reject the null hypothesis. We conclude that the proportion of college, well, let's just say of college age males whose favorite color is blue is not 0.42. So all we've determined is that it's not 0.42. Now, if I don't use this method, the Z method, you can also look for critical Z's that'll get you below certain scores, but this is the way that I would do it with StatCrunch here, and you come out and you multiply it by 2. That's the easiest way for me to do it. If you want to do the other way that we did in class, using more of StatCrunch, and we should come out with the same result, what we used was stat, and then instead of using calculators, we used proportion stats, one sample, and then we did with summary. We had the number of successes that we were given for this. The number of successes was 40. The number of observations was 150. And here were our null hypothesis was that it's equal to 0.42. We're going to leave this one alone because we wanted not equal to 0.42. If we were looking for just less than or greater than, we would include that. And then we hit compute, and what you see here is that you have a p-value over here on this far side that shows on the right-hand side 0.001, which if we go back and look, and our Z statistic actually is negative 3.805. So if we look and we go back, we notice that our Z statistic was negative 3.804, so with rounding issues. But here, if you used that method, you'll notice that our p-value was equal to 0.001, which again is less than 0.05. So in both cases, whether we did it with our Z-score or whether we did it using StatCrunch the whole way, we get the same p-value out. Okay, and we can make the same conclusion. So our conclusion wouldn't change, it's exactly the same. Now there's one other way to do this, and let's talk real quick about two-tailed hypothesis testing. When we're testing a null hypothesis where P equals some P ought versus it not being equal to it, if the confidence interval contains the P ought, whatever I originally had, so in the case above, maybe the 0.42, we do not reject the null hypothesis. So here we're going to use confidence intervals to determine whether or not we reject the null or not. However, if the confidence interval does not contain the P ought, the null probability, or the null proportion, we conclude that the population proportion does not equal the null proportion at the level of significance of alpha. So here, again, we have the same thing, the favorite color, right? And they did the survey, and it's 0.42 of males said their favorite color is blue, and we selected the same 150 students and so on. The difference this time is that we're going to use a confidence interval to answer the question. And so we're going to do it just a little bit differently. And I believe there is one on the test that asks you to use the confidence interval. So here what we want to do is we're looking to see, we have the same null hypothesis, right, that the proportion is equal to 0.42. And we have the same alternative hypothesis that the population proportion is not equal to 0.42, which I can't write. So if we go over and we look at the confidence interval and we find the 95% confidence interval from StatCrunch, remember our lower bounds and our upper bounds, if 0.42 is in that confidence interval, then we fail to reject the null hypothesis. And if 0.42 is outside of the confidence interval, then we reject the null hypothesis. Okay, so here's what we'll decide our decision. If p equal to 0.42 is included in the confidence interval, which I'm going to shorten with CI, then we're going to fail to reject the null. And if the proportion the value 0.42 is not in the confidence interval, look, I got a whole other part of the page there, then we reject the null. Okay, so let's go over to StatCrunch and we're going to find our confidence interval, and I'm going to write it in interval notation. So I'm going to write it as a interval here. So go back over to StatCrunch and we're going to close this one. What I'm going to do is I'm going to go to stat again. I'm going to go back to proportion. This time I'm going to do one sample with summary. All right, and I'm looking at the number of successes again is 40. I'm looking at the number of observations is 150. This time, instead of using the hypothesis test, I'm going to click on this confidence interval. And here I want a 95% confidence interval, so I can leave this alone, right? Oh, good, it added a comma. That's what I needed. Let's see if I can get it to 9.5. Oh, look, it keeps adding more. Hold on. Let's get rid of all of that. So I'm going to leave this at 0.95. All right, and then I should be able to just compute. So when I compute this, what you see is over here on the top side, I have a lower limit of 0.1959, and I have an upper limit of 0.3374. So if I go back over to where we were, here my 95% confidence interval was 0.1959 to 0.3374. And what you note is 0.42 is not in this. If I looked at it on a number line, right? So 0.42 is not in this. So in that case, I'm going to reject my null. I'm going to reject my H-odd. And I'm going to say, again, exactly what I said above. There is evidence to reject the null hypothesis. We conclude that the proportion of college-age males whose favorite color is blue is not 0.42 because we are not in the confidence interval. 0.42 is not in the confidence interval here. If I had had, and I don't, if I had had a null hypothesis that said, let's say that the proportion was 0.30, then I would fail to reject because that's in the interval right here. Okay. So let me know if you have any questions about that one. Hopefully this helped. And I think that'll do it. Have a good night.